All right. Hello, class. So I'm just going to do a quick review. It's just the one packet for fluid shifts. Um, and as you all already know, the most important thing is to try and memorize the packet as much as you can. You've taken a class from Dr. Beckstrom before, so you know how she tests. Um, but I'm going to make this review, and then we'll have review material for the other items that will be on the test, because there will be um, about 2 to 3 questions from the syllabus, and then a little bit more material that you guys went over. So let's talk about fluid shifts. Um, General fluid balance. So men and children have more water. So men generally have more muscle mass, and muscle mass has a higher percentage of water in it, percent of body weight. And then children like have a high metabolism, so they need more water to help that process. And then women um, are more likely to have more like adipose tissue. So, right, adipose tissue is less water, muscle tissue, more water. Um, Obese, same principle. Elderly, and if you know your grandparents are usually they have more tenting, they just have less water in general. Um, I think Dr. Beckstrand said something about prunes, at least when I took the class. So anyway, so the fluid in the interstitial space, so there's the intravascular space, interstitial space, and the intracellular space, right? So you have the plasma in your intravascular space, and you have a fluid in the interstitial space, your interstitial fluid, and it's the same components as plasma, except there are no proteins, so no like albumin or globulins, and there are also no red blood cells. So if you know the analogies that she gave for how big each one of those things are, those are too big to be able to go into the interstitial space. Also important that you know these numbers of percent of body weight of fluid in each of these spaces. So 7% of your body weight in fluid is in your vessels or your intravascular space, 16% in your interstitial, 35% in your intracellular. And then also important to know is that inside the cell, you can have more potassium, probably know that principle by now, more magnesium, sulfates, and proteins. So proteins, this is less albumin, right? Albumin is in your intravascular space. Its purpose is to have that osmotic or oncotic pull on the fluid. And these proteins are more like structural, functional proteins inside of your cells. And then outside your cell is sodium and chloride. So sodium chloride outside the cell, inside the cell, potassium, magnesium, sulfates, and proteins. So if you're ever going to have a change in your intracellular fluid, there must be a change in tonicity. So later on, we're going to talk about loss of pure water or gain of pure water. And whenever that happens, you're going to have CNS changes because there's a change inside of your of the fluid of your brain cells. So if you think about it, you're losing pure water, which is increasing the osmolality of the fluid inside of your vessels and your interstitial fluid. And so there's more particles per solution, right? Your normal is 275 to 295. So your osmolality increases when you lose pure water, and it would decrease when you gain pure water. And that's going to have an effect on your brain cells, right? So if you have increased osmolality outside of the cell, that's going to have the osmotic pull, and it's going to pull fluid outside of your brain cells. Um, and so in order to compensate for that, the cells might try to hold on to more particles, and then that's why you can only correct it at a certain rate. And we're going to talk about that later. So osmolality is the condition. How many particles per solution in a million osmoles per liter? I think that's the measurement, yes. And then tonicity is the effect. So osmolality is the condition, tonicity is going to be the effect of that pulling of fluid so that you have that the same amount of fluid per particle. Okay, so now we're just going to go through each of the stages. So a rapid loss of 2 liters of isotonic fluid. So if you have a rapid loss, it's not going to have time to lose fluid from your interstitial space. That takes time. So if you have a rapid loss of isotonic fluid, it's going to be pretty much completely from your vessels. And so shock is a condition of decreased perfusion. So you're not going to have as much blood or a high enough blood pressure. And so you're going to have shock. So types of events, hemorrhages, motor vehicle crash, severe laceration, GI bleed, all of these things, you're losing blood. And then anaphylactic reaction, you're going to have systemic vasodilation. So it's as if you're losing fluid because the fluid is not maintaining a pressure inside your vessels to be able to have sufficient perfusion. So that will be shock. Okay, a rapid gain of 2 liters of isotonic fluid. So this is going to cause pulmonary edema. So whether you're going to have peripheral edema or pulmonary edema depends on the speed. And part of this is because your pulmonary vasculature, there's a lot of surface area there and it's a lower pressure system. So if you flash flood with isotonic fluid, like if you have like a runaway IV or something like that, just going to have all that pressure. It's going to overwhelm the capillaries in your lungs first, and then you're going to have pulmonary edema. A slow loss of 2 liters of isotonic fluid is going to cause mild dehydration. So shock is like not enough fluid in the intravascular space, and then dehydration is a loss of fluid in your interstitial space. So if it's slow, it'll have time, your interstitial space will have time to compensate and it'll bring fluid into your vessels. So you'll be like lower in both vessels and interstitial space. But this is why you're going to have that like increased or decreased skin turgor because you're not have as much fluid in the interstitial space. And then also your mucous membranes will be sticky. So what causes this? Diarrhea occurring over 8 to 12 hours. And so she talks about like this hypertonic in like your colon, and then you have the isotonic fluid, and then goes like hypotonic in your mouth, isotonic, hypotonic. I think the general principle there is just knowing if you have diarrhea, you don't have, it's a faster process of the stool going through your body. And normally your body and your large intestine can make it hypotonic, but it doesn't have time to do that. So it goes straight from your small intestine to out of you. And so it's isotonic that's leaving your body. So that's why you're losing 2 liters of isotonic fluid. And then also another principle, I don't know if I have it in this PowerPoint, but she talked about like the football players, they lose a ton of like fluid and electrolytes and they can be given it back quickly. But if somebody loses something slowly, they need to be given it back slowly because the body compensates. And so you need to account for that. A slow gain of 2 liters of isotonic fluid, as we talked about, this is going to cause peripheral edema. And one of the main things that causes this is heart failure. Okay, a slow loss of 4 liters of isotonic fluid. So if you're thinking slow loss, isotonic fluid, let's kind of take this apart. You have slow loss. That's going to be intravascular and interstitial space. 4 liters is going to be more than the 2 liters, so we know it's going to be more severe. And then isotonic fluid, it's not messing with the cells. It's only messing with the interstitial and intravascular space. So more severe, and it's the same thing as the dehydration, right? That loss of fluid in your interstitial space, so it'll be severe dehydration. And this will be GI fluid loss with diarrhea plus vomiting. So you're losing a lot of fluid there. It's now a slow loss of 6 liters of isotonic fluid. So same principle, it's just more fluid, and now you're going to have severe dehydration and shock. So it's going to reach a point where your interstitial space can't compensate for your loss in your intravascular space. And so you will have that decreased perfusion to a point where you'll have shock. And the main cause of this will be burns. So skin is a protective layer over our bodies, protects us from microbes and things like that, but it also protects us from losing fluid. It keeps the fluid inside of us. So burns weep and they lose a lot of fluid. So now slow loss of 6 liters of pure water. So if you remember the principle of if you have pure water loss or gain, it's messing with your cells, also meaning your central nervous system. So you will have CNS symptoms because you're losing so much fluid. You're going to have that mild dehydration. Now it's not severe because now that we have the cells involved, your cells, if you remember the percentages, have a large percentage of your body weight in fluid. So now your cells have that compensatory mechanism. So it won't be severe dehydration; it'll be mild dehydration. And you will have normal hemodynamics again because now your cells are involved with compensating. Not necessarily a good thing, but it is, that's what happens. So you have normal hemodynamics, mild dehydration, and CNS symptoms because now we're involving pure water. And then drinking tap water, um, that was one of the things that I was confused about in class. Like, I drink tap water. Um, but if you drink too much tap water, then your GI system doesn't have time to like only absorb what it needs kind of thing. It just gets overloaded. And so at that point, it is an increase in pure water. And so that will affect your CNS symptoms. So if you, see something that says somebody's drinking a lot of pure water, that will cause CNS issues. And then how do you treat this? You treat this with D5W. So this is dextrose and with a little sodium and you give it slowly. So why dextrose? This is because what happens is you give dextrose, goes into your body, and a lot of the sugar gets absorbed. And so then it becomes more, um, it becomes more hypotonic. And so you're not correcting the loss as quickly. So correction should be no faster than 2 milliosmoles per hour. So if you remember, it's 275 to 295. So if you have a loss of um, a lot of fluid, then let's see, I lost my train of thought here. So if you have a loss of a lot of fluid, okay, so if you have lost a lot of fluid, well, you have a really high osmolality. So like 370, for example, milliosmoles. So you're only going to fix it. You'll want to go, 368, 366, back down to 275 to 295 milliosmoles. Um, okay. Now major loss of, oh, and then also the cause of this is like the hiker in Moab, which is where I am pretty much right now, which is funny. But yeah, so if you're like lost for a long time, you're losing that pure water in your vapor in your breath. So that's how you could lose 6 liters of pure water. Okay, major slow loss of 15 liters of pure water. So how does this happen? Diabetes insipidus, right? So they don't have antidiuretic hormone being produced, and so they're going to be diuresing, and it's going to look like clear water because that's practically what they're losing. And so pure water, right? You're going to have CNS symptoms, severe dehydration, because now even your intracellular space can't compensate for the loss of fluid, and you will have shock. Okay, I hope that makes sense. If any of you have any questions, then please don't hesitate to reach out. Sorry we couldn't do a live one. Like I said, I'm at my capstone and it's like a little crazy to try and like schedule that this week. So we're just going to do a recording. But please reach out to us if you have any questions and good luck with the test.